tetrahedral die has the numbers 1 to 4 in each face. When thrown, each side is equally likely to land face down. Let x be defined as the sum of the numbers on the face down side when the die is thrown twice. Complete the following table. So this is just simply 1 plus 1 is 2, 1 plus 2 is 3, so it's going to be 1 plus 3 is 4, 1 plus 4 is 5, and we're going to have 3, 4, 5, 6, 4, 5, 6, 7, and 5, 6, 7, 8. Hence, or otherwise, complete the probability distribution of x, which is given by the following table. So we can see we've already put in the values for 2 and for 8. If we think about 3, there's 2 of those out of the 16, so that is going to be 2 out of 16. For the 4, we can see in the table above there are 3 out of 16, and for 7 we can see 2 out of 16. For 6 we can see 3 out of 16. That's going to be 4 out of 16. Always a good idea to just quickly check that those do add up to 1. Calculate the probability of obtaining a sum of 5 or less. So 5 or less is these values. So that is just going to be 4 plus 3 plus 2 plus 1 over 16, which is 10 on 16. I don't think you really have to simplify, but it does simplify to 5/8. Determine the mean and standard deviation for x. Well, because this is completely symmetric, it should be clear that the expectation is 5. To get the variance of x, and I know this is a lot for 2 marks, but I always do the expectation of x squared, take away the expectation of x squared. So there we have to do 2 squared, so the squares are going to be just here. So it's going to be 4 times 1 over 16 plus 9 times 2 over 16, and so on up to 64 times 1 over 16. And then we're going to take away 5 squared from that. If you do all of that, you'll find that that comes to 2.5, and the standard deviation is just the square root of that, which is 1.5811.